Okay, so yesterday we left off at listing of all proper subsets, okay, of a particular set. Right, so do you all remember what is considered a proper subset? Something that's all inside the set. Something that is a set that's like a smaller set. Okay, so it is part of a bigger set. And more importantly, what's important as well in the definition of proper subset?
Elements. What is it called?
Consists of the same element.
Consists of same elements, that means an equal set. So.
A must not be equal to B.
A not equals to B, right?
And then the elements in B must be in A.
Elements in B must be A. If B is part of B, it will be is a proper subset of A now. Alright? So that's the important points. Okay. So let's look at exercise 1B. Wait, did I do practice now page 12 yesterday?
Yes.
Yeah?
Okay.
No, right? Yeah, I just covered this one. Okay, let's look at practice now on page 12 first.
We did that one already.
We did? Did, huh? Did we? I don't think we didn't, right? So, page 12 practice now, I haven't do one, right? Okay, let's first practice listing of all the proper subsets, okay, of these two questions over here. Okay, in part 1, what would the proper subsets be? Okay, we have one set that consists of what elements? 7 only. Then 8. Anything else? An empty set. Okay, good. What about part 2? We have single ones A, B, C. And then A, B, and B, C.
AC.
Then A, C. Anything else? And empty. Okay? Okay, let's look at question 8. If we have H, it will be such that the elements are rational numbers, and then after that, for set I, the elements are containing integers only. Okay, we want to know whether I is a proper subset of H or not. Okay, what do you think? Do you think I is a proper subset of H?
Yes.
Yes? Okay, so all integers are also rational number. Right, so answer is yes. So to explain it, all integers are rational numbers. Okay, so if we review the definition that we have for proper subset, okay, so we see that all elements in I are part of H, and more importantly, I is not equal to 0. ratio fraction similar.
Then we should insert the date. Then
Yeah, because it's 5 is
Oh, it's 8. It's
no, wait.
okay.
okay. Now let's move on to, and can I move on already? Let's move on to 1.3 intersection of two sets. Okay, so sometimes it may not be a proper subset or subset. Okay, so sometimes we could be looking at the intersection itself, whereby two circles actually overlap one another, which is the one that most likely you commonly see in your memes. Okay, so if you were to consider a set A that has 1, 2, 3, 4, 5 in it, and then a set B that has 3, 5, 6, 7. Okay, so in order to draw the Venn diagram, so for A itself, I would see that I have 1, 2, 3, 4, sorry, 3, 4, 5, 6, 7. Okay, so because 3 and 5 are common between these two sets. Okay, so this will be how I draw my, sorry, this one is 106 on my top right. Okay, 1, 2, 3, 4, 5, 6. Okay, so this will be how the Venn diagram would look like. Okay, the intersection refers to the overlapping parts. So this part itself is what we call intersection. Okay, and to denote this part, right, okay, we use the notation A, and then after that this inverted U kind of thing. So A intersect B, right? This is an entire set on its own. And the elements in A intersect B will contain 3 and 5. So when we read this symbol, we read it as A intersect B. Yes, sorry. Why would it include empty set? But the set is not an element of the of A and B one. Emptiness is one thing, but it may not refer to empty set. Empty set is something. Emptiness is nothing. You understand? So the intersection itself does not include the empty set. Empty set is not an element because it's not listed inside. You understand? Okay. But there is emptiness, but we do not represent the emptiness. There's no notation for it. You understand? Okay. Okay. If you understand this, sorry, just take it as it is, okay? So let's look at practice now 5. Okay, we have these two sets over here. One is a multiple of 6 between 0 and 18. The other one is a multiple of 3 between 0 and 18. Okay, 18 inclusive. So in part 1, we want to list all the elements. Okay, so C and D, right, actually would have these elements over here. You should know very quickly what is your multiples. Is there any question from just now? No. Sure? So in part 2, we want to actually find out what is C intersect D. So what would the elements be inside this set? What are the elements? Sorry? 6, 12, and 18. Now how do we draw the Venn diagram? Do we draw in this manner? Should we draw C and D like that? Then C will have your 6, 12, and 18. And then this will have 3, 6, 3, 9, 15. Would this be the Venn diagram that you would draw? No? Okay, so actually this will not be a correct Venn diagram. Okay, so the correct Venn diagram should be that C is inside of D. Okay, whereby the intersection in this case is a part of D itself. It is a proper subset. So it does not mean that intersections must always look this way. Okay, it could actually be a proper subset. There are different ways of overlapping. Huh? Yeah, so in this case we can say that C is a proper subset of D. But this itself is only telling me C is proper subset of D. But this symbol does not say that it is a set. This is not a set. This is a set. You understand? So use correct notation. Okay? So this does not refer to a set.
It just says it's inside.
Naming wise, okay? This naming wise, it just reads as C is proper subset of D. Okay? But this does not have any, you cannot actually say equals to certain elements. Okay? Because this does not refer to a set. It's not a name of a set. Okay? Whereas this can be a name for a set itself. Okay? So you can write it in this manner, but you cannot write it in this manner. Are we clear about the notation? Okay, and then part 4, it asks whether C intersect D is it equals to C. It asks you to explain. So what do you think? Is C intersect D in this case equals to C? What does this actually mean? It means that the question is trying to ask, is this set an equal set to C? The answer is yes. Okay? So yes, it is. Right? Because the elements of C intersect D are exactly the same as the elements of C. questions so far?
So the left side, what?
The what?
The left side.
This one?
What?
This one? Cannot. Yeah. This is not a correct representation. Okay, let's look at question 2. We have the set E that is containing all positive integers that is a factor of 12. Okay, and then F is containing the elements such that it is a prime number between 5 and 13 inclusive. Okay, so you want to actually list out the elements, okay, of E and F. So what would the elements of E actually contain? E. 1, 2, 3, 4, 6, and 12, right? And then F would be 5, 7, 11, and 13.